Since I'm CTO, technology decided to give us some work. So don't worry about microservices. If you don't know the term or monolith, I am here to give you very fast crash course what it is, so that you would not be intimidated in later discussions and feel comfortable what it is about. It will not be too technical presentation or discussion, just to match everyone's level. So our agenda, we will go through introduction to microservices. We will discuss key concepts. I will show you benefits. I will go through challenges, what we encounter implementing microservices, what are the best practices, some examples of potential use cases for fintech companies, and conclusion. By the way, questions you can ask anytime, just raise a hand and I will answer them during the presentation. So what is microservices? Microservices is architecture philosophy, how you design your application. So you probably heard the term monolith. This is usually what our current legacy systems are working, especially in banking sector. And in monolith architecture, we have all the layers, all the components, basically either in the same code or in the same server or in the same stack. So we have UI, core system, application level, presentation, everything, usually running on one or more servers, but it's like one chunk. You log into a system and everything. And usually it has single database where the functions are distributed between different tables, and that's it. So how microservices are different from this architecture, that we split our main application into the separate functions, and each of them exists as a separate system. It has its own database. It can have its own programming language. For example, core service can be written in Java. Some ML stuff usually is written in Python, and so on and so on. And these services, they communicate with each other through the API or some service bus and work independently. And main thing is that you can scale them independently, or if one of them crashes, your main system stays online and gives a better user experience. So as following microservices, so key concepts are that you use any database for specific service, because specific functions usually work best with your database. So for example, for a search service or your user data, the best database is Elasticsearch. And of course, you can use some SQL database for that one, but Elastic is much more fit for that. And in microservices, you easily can do that, because you can choose for that part a specific database. Also, these services usually interact between themselves using REST APIs. This is like default. gRPC is the second one. And you can scale them independently, as I said. If you follow cloud native standards, that means that each service can be scaled independently horizontally, and you can match the load or react to failures. So what are the benefits? So as I said, you are flexible when you are developing in microservices. So you can start with MVP, so the most core functions you need, and you can develop independently. This is the key concept, that since each microservice lives in its own world, it's not dependent on another one in development phase. That means you can have distribute development to the parallel teams, and we are not blocked by each other. So for example, if you want to add some features in the UI, you don't need to wait until core team finishes their thing. You can add them in advance and just agree on a protocol, which leads to much faster development, except in Monolith, where you have to put all the features into releases, wait a few months until testing is done, and then go to production. As mentioned, scalability. Since each microservice can be scaled independently, you can easily scale only parts you need, and you can scale horizontally. So your application can utilize the resource efficiently, and that's very important running in cloud, where you can get resources basically on demand, and you can make use of this concept the best, because you have a traffic burst, you scale it, you handle the traffic, for example, at the end of the year, downscale for the rest of the year, and do not overpay for infrastructure. And the same feature gives you resilience. If one part crashes, whole system stays online, and users with most work with reduced functionality. But what challenges do we get when going with microservices? Because in Monolith, it's pretty easy. You have one developer team. They work on a product. They know it end to end, and develop whole stack. So when going microservices, suddenly you have different languages, different technologies, different databases. So these teams usually grow, and we need to interact. So it's a challenge to coordinate between themselves. So there we have to have strong architecture, strong guideline set, and everything. Other thing from performance-wise, in Monolith, usually these services are running in the same system, and they interact with syscalls or share a memory. So interactions between are very, very fast. But when you introduce microservices, they can be running on containers or virtual machines or even separate physical machines. We add this network latency. And in some architectures, that can increase latency by a lot if you are doing like sequential requests, not parallel ones. But that also has to be accounted in the architecture. And some data management issues can arise if you are like not synchronizing data between microservices properly, or you have not implemented it. All right, what is the source of truth, or what are the replicas? And another very important thing, I would say, that without implementing DevOps culture in your company, microservices implementation can be challenging, because with increased complexity, to tackle that, you need to have some automation in place. And the more automation you have, the better microservices work. And doing it the old way with manual releases, manual deployments, with sufficient size of the system, microservices can be just too slow for you if you are not following DevOps practices. So what are the best practices implementing microservices? So on what, how to say, pitfalls do not encounter. So first, choose what to put into microservice. If you have one function of a system and split it between 3 microservices, but from a helicopter view, it does one function, and if you remove it from your whole application, and it cannot work independently, it's not like 3 microservices. It's still like Monolith, but you just distributed it. So microservice definition should be at least it has to work independently and does not crash. So if you have like multiple parts of it, do not follow it. Another one is use API gateway. Do not expose microservices directly to end client, because API gateway can offload some authorization, rate limiting, and other functions from microservice, input some protections from DDoS and so on. And third part is monitoring. In microservices and containers, whole concept how you monitor your systems changes compared to monoliths. And monolith, usually you just install some monitoring agent, get some custom metrics, and that's it. In microservices, you have to change the whole approach, use different tools, and gather the metrics in different way. And third one is testing. So have as much as automated and integrated testing as possible. And here is from my very good source, Byte by Go, for architecture diagrams, also the same principles in graphical way. So they also recommend containers, but it's not a must. As I said, microservices you can implement even with physical servers. It's not about where you run it, it's about philosophy, how you run it. And I have covered some use cases for Fintech. So, for example, payment processing can be split into separate microservices where we can have payment gateway service developed as a one microservices and added to your architecture. We can have fraud detection as another microservice. And why it's a good example, because it's like full functionality. So if we remove it, we lose one function of your whole system, but whole system can act without it. You just will be working in reduced functionality. So for KYC service also can be developed and worked as a separate service. And in conclusion, so what microservices can give us? It gives us faster development time, and you can develop separate features in parallel. It gives you horizontal scaling, which you can react with load, and it increases your resiliency. And in turn, these two give you faster time to market. Instead of like working under the hood for 1 or 2 years on your product, you can release it feature by feature, but as fast as you can basically develop it. And that's basically it. Quick crash course into microservices. So then unless some questions are, I can answer. Ben, stage is yours.